So now take a scope block. Okay, that one you will get here. Okay, sinks. Okay, sinks. Take a scope block. Okay, so and take a constant block and then search for sum block. Okay, sum. Okay, so take this block. Okay, so then search for PID controller. PID. Okay, so select this one. Okay, place it here. So after that search for ABS. Okay, ABS block. Take a ABS block. Okay, add ABS and then for repeating sequence block. Repeating sequence. Okay, so take this block. So after that search for relation. Okay, relation. Okay, so take this block. So, so these are the blocks we are going to use in this project. Okay, so let's do the connections. Okay, so now take a DC voltage source, double click on that, make the voltage as a 15 volts. Okay, so after that take a series RLC branch, double click on that. Here select the inductance. Okay, so and inductance value must be 35.62 micro henry. Okay, so for the micro we use a E. Okay, click on OK. Connect this one. Okay, so and after that take a MOSFET and rotate this one. Okay, place it here, double click on this. Okay, and deselect the measurement port. Okay, and click on OK. Okay, so okay, after that copy this one. Okay, paste here. So double click on this, select capacitance. Okay, capacitance and the value is 28.57. okay, 57 and e to the power minus 6. Okay, and click on OK. And another one, take inductance and place it here, double click on that. Here give a value of 14.25 e to the power minus 6. Okay, click on OK. Now do the connections. Okay, and negative to the here. Okay, so and this one to here. So now rotate this one. Okay, place it here and make the connections. Okay, and here. Okay, so now take a diode. Okay, double click on that and deselect the measurement block port. Okay, and click on OK. Place it here. Okay, okay, so now make the connections of diode. Okay, and here, and you require another one capacitance here. Okay, so rotate that one and do the connections, this one to here and this one to here. Okay, so and at the last you require a resistor. Okay, so for that copy this block and double click on that, select R. Okay, make the R value as 10. Okay, click on OK and connect the resistance. Okay, so now take a voltage measurement block. Okay, okay, so voltage measurement block, take this one, place it here, connect here and here. Okay, so connect it to the scope block. Now take a subtract block. Okay, flip this one, go to the rotate and flip, and here, okay, so like this, make this flip and take a constant, okay, so flip this one. Now connect the constant block here and subtract block to this point. Okay, so now flip these blocks. Okay, so right click and go to rotate and flip block. Okay, and this block, okay, and also this block, and also this block. Okay, click on flips. Okay, so now double click on PID. Okay, so here change the integral to 7. Okay, and enter. Okay, so and in a repeating sequence, double click. So here in time values, put 0 space 1 divided by 25,000. Okay, so after that output values must be 0 and 1. After that click on OK, check the values 0, 1 and 25,000, and output is 0 and 1. Okay, and click on OK. So now make the connections. So relation operator is connected to the MOSFET. Okay, so and here to here, this connection here, and PID's output is connected to here, subtract block is connected to PID. Okay, so this is the connections. Okay, check the connections, and now make the constant as a 6 value 6. Okay, so this is the connection of your closed loop simulation of SEPIC converter. Okay, okay, so once again check the parameters. Okay, make it as a 15 and click on OK. So resistor 2 ohms. Okay, so constant make it as a 6 or 8 something. Okay, 6 here. The output I will get as about 6. Okay, so if I change the input voltage, that will be not affected to the output voltage. Okay, so let us check in one condition. Okay, here I given the 6. Okay, so here 15 watts. So now click on run option. Okay, so after run click on scope. Okay, so here zoom in. Okay, okay, so here you can see the output supply is near to the 6. Okay, so 5 above 5, the output is above 5. Okay, so in next condition let us change the input voltage to 20. Okay, so before it was 15, now I have entered the 20. Okay, so now click on run and check the output. Okay, so here zoom in. Okay, so it is around near the 8 value. Okay, see here. Okay, output is around 6. Okay, so the input voltage varied, then the output will be remains the same. Okay, so here I will give a 10 value as 10. Okay, so now click on run. The output will be near to the 10. Okay, 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 so it is a near to the 10. So by this you can check the output of a SEPIC converter. Okay, thank you.